Hiya! On today's episode of Preaching to a Seven, we'll have a look at an own integration question. You're given the speed of an object at time t seconds given by the differential equation, and then you're asked to model with it. At first glance, this equation doesn't seem too bad. But of course, the devil is in the details. So, without any further ado, let's get cracking with part 1. This question asks you to use partial fraction decomposition. However, since you have not seen denominators in this form, they will have to give you the template, aka the right-hand side, on the exam. So, as per usual, let's equate the coefficients. Adding the two fractions on the right-hand side, simplifying it a little bit, and there goes your expression. If we look at the coefficient of x, coefficient of, say, v squared, we know that a plus b is equal to 0, because 1 is effectively 0 v squared plus 0 v plus 1. Similarly, if we look at the coefficient of v, c is equal to 0. And if we look at a constant term, a is equal to, 4a is equal to 1. Therefore, a is 1 by 4, b is negative a quarter, and c is 0. Easy peasy. Part 2. Now we would like to solve this equation. Okay. Now, reading the examiner's report, this seems to be the bottleneck for the question. How are we going to solve this? Well, first, notice that this equation is separable. We can then use the result from part A to decompose this. Integrate both sides. Be very careful with the second term. On the right-hand side, you will get negative kt plus c. Okay, so you're halfway there. How do I go from here to here? You can either do it by inspection, or you can simply use a substitution. For example, u equals to 4 plus v squared. I will not bore you with the details. After obtaining this equation, how are we going to bring it to this form over here? First, notice that the k is still here. You're not expected to solve for k. 2, you're also given k is a positive constant. V is equal to 4 initially. This means that when t is equal to 0, v is equal to 4. This would then help you to find the value of the constant of integration. So let's plug in this initial value. How do we combine logarithms in this case? Once again, be very careful. They do not have the same coefficient. So what I'm going to do is that I'm going to factor out the 1/8. That will give you 2 ln of 4 minus ln of 20. This can be written as 1/8 ln of 16 minus ln of 20. And therefore, C is equal to 1/8 ln of 4/5. Cool. Moving on. How can we then isolate V from this? First off, we need to find a way to combine the two logarithms, which is quite similar to what we just did up here. So if you factor out 1/8, you're down to 2 ln of V minus ln of V squared plus 4. And this is equal to negative KT plus 1/8 ln of 4/5. Okay, I'm going to then multiply both sides of this equation by 8. I'm going to combine the logarithms. I am then going to exponentiate both sides. This step is crucial, and it is also the one that people are very inclined to screw up. So I'm going to do it step by step. On the right-hand side, we can just use index laws to separate the two terms that are being added. In other words, we should have this. 2. Notice that e to the ln of 4/5 is simply 4/5. Now we have obtained an expression that is actually part of the solution. From here, I don't think it is that much more complicated. All you have to do is isolate for V. Bring everything with V to one side. Divide. And see if it is the form that they're looking for. No. Okay. We want an expression for V, not V squared. We also want the numerator to be a constant. So what we're going to do to denominate or to this fraction is going to be multiplying both the top and the bottom with e to the 8kt. This does not change the value of the expression. And now you can take the square root of this. You may have another question. Why do we only take the positive square root? That is because you're given that v is the speed, not velocity. So by definition, v is positive. So this is the end of the 9-mark epic. Part 3. After 1 second, the speed of the object is 2 meters per second. Find the value of k. This is crucial. Even if you are unable to derive the answer in part 2, you are encouraged to take that answer to solve part 3. You are given v in terms of t. Take it and move on. We know that v of 1 is equal to 2. Well, that means, of course, this has to be true. Squaring both sides. And this is the end of the question. As per usual, I sped ran through the basic algebra, and I only take my time when there is stuff that needs more explanation. Hope you find it useful.